Hello students. Today let us look at the units part of the units and dimensions chapter. When physicists talk to each other across the world, they need to have a common language. When describing physics laws, they may be comparing quantities that they have measured or calculated. To be able to make sure that they understand each other, all the terms and the units of measurement have to be standardized. So there is a need for standards to be able to communicate. And all the physics laws are expressed in terms of physical quantities. Some of the physical quantities are like mass, length, temperature, time, force, density, speed, etc. We don't have to understand all of these terms right now. As we progress, we are going to learn them. But for now we need to understand that these quantities are used to describe and understand physics laws and to be able to communicate with each other. And to have a standard, there are many standards, but the most common standard is the SI system, the International System of Units. So the SI system has been developed and has been shared across the world so that people, when they share information and they share the values, they are the exactly same all over the world. Is it necessary to standardize all the physical quantities like mass, length, temperature, force, density, speed? Luckily, no. There is no need to standardize all the quantities that we may come across in physics. Scientists have identified that there are 7 base quantities that, if standardized, the rest of the quantities can be expressed in terms of those 7 base units. What are those base? Mass, length, time, amount of substance, temperature, luminous intensity, electric current, temperature. So there are 7, and these, the names, their names and symbols are given. So the derived quantities and the other quantities can be expressed in terms of the base quantities. Let's take an example. For example, force. Force in physics is defined as mass into acceleration. We don't have to know all of these terms right now, but it is sufficient to understand for now that it is mass into acceleration. And acceleration is defined as distance by time square. So what force becomes is mass is measured in kilograms, kg. Distance is measured in meters. Distance is measured in meters. And time is measured in seconds. So force becomes kg meter per second square. Similarly, velocity. Velocity is defined in physics as distance by time. And distance again is length and is measured in meter, and time in second. So what we have seen here is there is a need for a standard units so that scientists or physicists can communicate with each other, and those units have to be standardized. Scientists have identified 7 base quantities that have been standardized, and these are given here: mass, length, time, amount of substance, temperature, electric current, and luminous intensity. And the rest of the physical quantities, whatever they may be, they can be expressed in terms of these base units, and there is no need to standardize all the physical quantities. So this is what we learned today. See you in the next class.